Hello everyone, welcome back. This is Engineer Hafsan Wasabi. So this is a continuation of our math revision playlist. So in this question, we're having one that says solve the equation. So before we begin, do not forget to like and subscribe to the channel. So it says solve the equation. We're basically having an equation that has x to the power 4 plus x cubed minus 21 x squared minus x plus 20 being equal to 0. So basically, the first thing I want you to understand is that this is a fourth degree polynomial. Now, the highest degree of a polynomial shows you how many values of x you are supposed to find. That is, if you have been told to solve the equation. Now, when one asks you to solve the equation of whatever degree, could be the first, second, third, fourth, regardless, the key is always to understand that what you're looking for, like in this particular case, are the zeros. They are called the zeros because they are at the point where y is 0. So all the possible x values are basically the values that the graph will cut in the x-axis, that is. So in this case, whenever you're solving a fourth degree or third degree polynomial, it's best to apply, let me just say in simple terms, a guess and check approach. We all understand that if we have a polynomial as ax squared plus bx plus c, we know this is of the second degree. And solving the factors or the values of x for this one is quite simple for a good number of individuals. But even if you don't, do not worry. In the end, I will explain how to go about solving it. But now, in this case, we're having the leading to be the power of 4, so we have to find means of reducing the polynomial until we reach a point where we're satisfied, and we know for sure that we can solve it using the sum and product technique. But I'm not saying that it will always work for the sum and product. At times, you might end up having a second degree polynomial that can be only factored out by the use of a quadratic formula. But doesn't mean that you're wrong. If at all your math allows you to use calculators, then you find that value. But if at all it doesn't, then trust me, it will just be a factor, then times the quadratic second degree polynomial. Anyway, let's begin and try to give in the first approach. So let's try and assume that if I pick a random value right now in my head and plug in for x, I'll get 0 on one side of the equation and 0 on the other side of the equation, which holds true and satisfies my equation. So I'll try and say, okay, let's let x be equal to 1 and see what will happen. So now, when x is equal to 1, it means that at each point here, I have to put 1 for every x value. So it's going to be 1 to the power 4 plus 1 to the power 3 minus 21, and that's 1 squared minus again another 1 plus 20, and this is equal to what? 0. Now let's do the basic math. So we know this is 1, it's going to be another 1. Okay, so that's going to be 21 minus 1 plus 20, and is equal to 0. Now, will this give me 0? I also don't know, but we can try and compute. 1 plus 1 is 2, minus 21, minus, I can do up a minus 1 plus 20, to give us like a plus 19, and then it's equal to 0. Then 2 minus 21, okay, that again will give us like a minus 19 plus a 19, giving me 0. So minus 19 plus 19, that's 0 being equal to 0. So basically, this holds true, that x is equal to 1 is one of the values of x that makes the entire equation and be equal to what? 0. So it is part of the zeros of this fourth degree polynomial. Now, once you find the first value of x, it's not in all cases that everybody will guess 1 at that particular time interval. You can guess any random number, but don't just guess numbers that are irrational. Let's just pick numbers that are rational. You get the point? Like numbers that are a bit more realistic. The last value, which is 20, gives you a hint of the type of numbers you need. So it's like plus or minus 1, plus or minus 2, plus or minus 6. Just keep on going. Trust me, you won't even reach 5. You even find the first 0. So, with this said, let us try and find means of reducing this polynomial to the third degree. When you find the first value of x, it's best to find the second value of x by finding a degree which is 1 less than the degree of the leading x in the original question. So for me to reduce that, we apply something that is called synthetic division. So in the synthetic division, all I have to get is the coefficients of every term, including the constant of the fourth degree polynomial. So I'm having 1, then I get another 1, then minus 21, then minus 1, then 20. Then again, remember, you can only apply synthetic division. That statement won't make sense right now, but what I'm trying to say is that I'm only applying synthetic division by using that value of x that I know gave me 0. Because synthetic division is the one that's going to help me know exactly my third degree polynomial, because 1 degree less than the original degree, which is a fourth degree, will give me a third degree. So what I'm trying to say is this. If at all you apply a synthetic division and then you get maybe the last value of your synthetic to be 0, it means that the remainder is 0. But if at all you get something else, it means that the remainder is nothing other than that value you found. But it can only be 0, which proves that that's a factor. But anyway, let me try and explain this while solving. So let me put 1 there. The first approach to do is always drop the first value, 1, and say 1 times 1 is 1. Then again, you sum up this point, which will give you 2. Then 1 times that 2 will give you what? 2. Sum up this will give you what? If you sum up that guy with that guy, you get negative 19. Then 1 times neg 19 is neg 19. You sum this up, you get negative 20. 1 times that, you get negative 20. So at the end, you get 0. So this value at the end is called the remainder. There are certain principles of theorem in mathematics that we should know at hand. For instance, you need to know what the factor theorem states. The factor theorem states or tells us to say that whatever value of x I plug in for the function that I have at hand, could be this one or any other function, provided that when I plug in that value of x in my function, if I get a 0, then that value of x I picked is the factor of my function. But if I plug in for x, and that value I get is any other number other than 0, it means that that value is a remainder. That value will rather say, that value will give us the remainder of our function. That's why we have the remainder and the factor theorem. So now once you have these coefficients, these will give you the coefficients of the third degree. So this will be x. Now you start reducing by 3, so it's going to be x cubed plus 2x squared. Remember, the degrees should be reducing like 4, 3, 2, 1, like 4, 3, 2, and you get the 1, then a constant, same thing here. It should be like minus 19x, then minus what? 20, and it should be what? 0. Now I have to pick another value of x, because, if I get 1 already worked for my first equation of the fourth degree. Now I have to see the third value of x from the third degree to see to it that it gives me 0. Now, even if I did try to pick 1, at times the same value might be repeating, so it might even work in the next polynomial. So if I put 1 here, by inspection, guys, we know that it's going to be 1 plus 2 minus 19 minus 20, right? So we know that, okay, so this is like plus 3. So, okay, plus 3 minus that. We know that this won't give us 0. So we know that 1 will not work. So let's try to let x be equal to, maybe the negative form of 1 would work for us. So let's say negative 1 cubed plus 2, then negative 1 squared minus 19, then negative 1, then say minus 20 is equal to 0. Now be mindful of this. Whenever you have a value such as maybe, say, negative a raised to n, if n is even, regardless of the value you have here, the answer will always come out what? Positive. But if n is odd, the value will always come out what? Negative. Now, what are even numbers? We're talking about those numbers that are divisible by 2. Then odd numbers, talking about numbers that cannot be divided by 2 in simple terms. Talking about those numbers that are odd, like 1, 3, 5, 7, and so on and so forth. So those are examples of odd numbers. Yeah, and I know the odd is not that odd that you're thinking about. Yeah, and we don't have young numbers. Anyway, let's go back to the truth of the matter. So I'm having minus 1 to the third, which means I have to end up getting a negative answer. So it's like minus 1. I'm having negative 1 to the second, which is even. So this means I have to get a positive answer. And then 2 by 1, that's basically 2. Then this one is like a direct thing. So give us like a plus 19. Then minus 20 is equal to what? 0. So it's like minus 1 plus 2 is like 1 plus 19 minus 20 is equal to 0. By inspection, without even finishing my question, I feel like we've all seen that this holds true. So x being equal to negative 1 tells us the truth that it is a factor of the third degree polynomial, which means that once I plug in for the function of the third degree, I'll get 0, which makes it a factor, which makes it one of the zeros. I know at first glance this might sound a little bit tricky, but you know, going through things over and over again doesn't mean you don't know. It just means that you are trying to make the best out of the knowledge you have. So always go through these things, even if it means watching the video over and over again. If it means you have to do that, don't feel lazy, just do it. So, commercial break is over. Let's go back. So now that I have my second value or my second zero, I can again try and apply the same technique I did here. Remember, I did find one value and then I said to myself like I needed a lower degree. So I'll be doing the same again this side. So now I have another value of x, which is a 0. I can actually reduce it now again. So now it was a third degree here. I'm trying to reduce it to a second degree. How? Synthetic division. So I'm going to put the values with the coefficients. I have 1, 2, negative 19, and negative 20. Then I'll get that value of x I made it true, which is negative 1. I know you're wondering where these numbers are coming from. Please don't be lost. These numbers are coming from the coefficient of all these terms I'm having here. As you can see, x cubed basically is x to the power 3. It has 1 in front. 1 is mostly not shown in math because it's regarded to be an abstract figure. So that's the case. So if I drop my 1 there, I say minus 1, I say minus 1 times 1 to be minus 1. Then I sum this portion up. If I say minus 2 plus minus 1, that is basically positive 1. And again, minus 1 here, boom, multiplies that. And this gives you a minus 1 again. If I sum this up, I get a minus 20, then a minus 1 by minus 20 is positive 20. Basically, I get 0. So this proves that it is a factor because my remainder is what? 0. So now, what am I having? I'm having something like x to the power 2 plus x, then minus what? 20. I know this is equal to 0. Wow. Now, I can't start guessing at this point. Guys, this is something we've been solving like since back in the days. Those days, I don't even know those days, but obviously you did solve this at one point in life. Now, there are times where you might have a second degree polynomial that will not hold true for perfect values of factors that you might end up having. Sometimes you might end up having an absurd condition where you can't really find the factors. Like you might come across a condition whereby it would be very difficult for you to find the factors, but in this case, you can find the factors to be like 4 and not minus. It should be a positive, so this one should be a negative because of like if you sum up, I have to get a 1. Yeah. In this case, these factors are quite simple to find because it's in a case that makes something make more sense. Yeah, but if at all you can't find the factors, just get it as this and put it as an answer. So if at all you couldn't find the factors, then the values will be you say, okay, my first factor is x. Remember, the first one was like x being equal to 1, right? So which means x goes the other side will be minus 1, which gives you the first factor. Remember, the second one was like x being equal to negative 1, so I take it the other side to be like x plus 1, which would be second factor. Then if at all this couldn't be solved, it would just be like x squared plus x minus 20. Okay? And then you just say is equal to 0. Then you have solved. Okay? Yeah. But I know this is not what is at hand. That was just food for thoughts. In case of cases. Yeah. So now all we have to do, remember, if the leading term of x squared has a coefficient of 1, you can just say, okay, this is x minus 4, then again x plus 5, and all of this is equal to 0. And I can actually solve this. I can let the first parenthesis x minus 4 be equal to 0, and this will be like x being equal to what? 4. I have my second 0, and again x plus 5 being equal to 0, and I can just say x is equal to negative 5, just like that. So I have found all my zeros. Therefore, I'm having x being equal to 1. Then again, I have x being equal to negative 1. Then again, I have x being equal to 4. And finally, from x being equal to negative 5. just like that. So that's how you solve this equation. Other questions might come through where they say, oh, look at it now, find the domain. The domain of all polynomials will always be from negative infinity to positive infinity. Always remember that. All right, thanks for watching. My name is Engineer Hussein. I'm WhatsApping. If you have any queries, remember you can reach me out on WhatsApp on the line 077 149 5252. And remember, slow progress is better than no progress. Let us strategize before becoming a statistic. Let's try and push for that A+.